Okay, so I've already, on this one, I've already written the vectors that we just calculated, which we're going to use for the directions. Curtis, I can't hear you. If you can do it without visualizing it, then more power to you. Okay, I think you probably need to visualize it in some way, but here's these three that we just calculated, right? Now, the vector, which is the vector of the weight that's being pulled down, right, we know the vector of that one. That is 0, 0, negative 480, because it's a weight and it's pulling straight down. Now, what we would know is that if we add up all of our vectors, u plus v plus z plus w, it's 0, because this weight is not moving at all. Okay. And if you subtract the w vector from both sides, that means that u plus v plus z, the three ropes that are pulling up, are balancing the one that's pulling down. They have to be equal to each other. The weight is 480 pounds, pulling down. So again, these are just going to be for the directions we use these. It's not the magnitude. We can't use them for the direct magnitude of the vectors. Okay. So same picture. I actually copied it and pasted it. Okay, so actually our u vector will be the magnitude of u, whatever is the tension in the cable, times a unit vector in the direction of that. Okay, so how am I going to find a unit vector in the direction of this vector here? Right. Find the magnitude, right? So we would have to do the magnitude of u sorry. It's not really correct to say the magnitude of u, but the magnitude of this here is the square root of 2 squared plus negative 2 squared plus 1 squared. What is that? Two squared plus negative 2 squared is 4 plus 4 plus 1 is 9. Right? So we would know that the magnitude is 3. Okay, if you go over here, the magnitude of this one is the square root of 0 squared plus 2 squared plus 1 squared, which is 5. And the magnitude of this one is the square root of 9 again, which is 3. So here's my u vector, right? My u vector is the magnitude of u, which is the thing that I don't know, times 2 over 3, negative 2 over 3, and 1 over 3. See, I'm just dividing this vector by 3. Right, so notice, because this has a magnitude of 1, all of the magnitude comes from this. This is just telling you the direction that the rope is pulling. It's not telling you anything about the magnitude. Okay. The same thing here. For the v, it's the magnitude of v times, and here it is 0 over the square root of 5, which is 0, 2 over the square root of 5, and 1 over the square root of 5. Okay, and the last one, doing the same thing. what would be the components of the unit vector in the direction of z? Here's the direction of z, and the magnitude of that vector is 3. So negative 2/3, negative 2/3, 1/3. Okay, and again, the w vector is 0, 0, negative 480. But when you move the w to the other side, now it's a negative w. What will negative w be equal to? 0, 0, positive 480, right? So now we need to set up an equation where we're adding these three vectors together and making it equal to that. And that's what we're going to do on the next slide.